Today let's discuss about power of a lens. The most important characteristic of a lens are two. One, its focal length, and second one, its power. For a biconvex lens, we have already studied lens of two types, biconvex or simply convex lens. We talk about its converging power because a parallel ray falling on a biconvex lens after passing through the lens converges to a point. So the power of a biconvex lenses, we usually talk about the converging power. So convex lens is also called a converging lens, and hence power of a converging lens is positive because we are measuring to this side. So power of a convex lens is positive. But in the case of a diverging lens, when a ray of light passes through a diverging lens, it is diverging away. Instead of converging to a point, it is diverging away, and the focus is an imaginary point. It appears to diverge from a point. So this type of lens is called a diverging lens. Concave lens is called a diverging lens. Convex lens is called a converging lens. And the power of a diverging lens is negative. Now let us see what do you mean by power of a lens. In standard 10 you had studied that power of a lens is the reciprocal of its focal length measured in meters. Remember, it's measured in meters. So P, power, is reciprocal of focal length, which is measured in meters. And unit of power is diopter. So 1 diopter is 1 meter inverse. Meter raised to -1 means per meter. 1 by meter is diopter because 1 by F. F is in meter. So 1 by meter, that is what is diopter. Now in your textbook there is a definition for diopter. Definition for power. It is like this. Power of a lens. The power of a lens is the tangent of the angle by which it converges. I told you for a convex lens, the light converges. For a concave lens, it diverges. So if you are talking about a concave lens, instead of converges, the term is diverging. Tangent of the angle by which it converges light. Converging power. Actually that is the meaning of power. Converging power or diverging power. Converge ചെയ്യാനുള്ള കഴിവ് അല്ലെങ്കിൽ diverge ചെയ്യാനുള്ള കഴിവ്. Now there is a derivation, small derivation for which refer this figure. It is figure 9.20 in your textbook. So in this figure you can see a ray of light meeting at a point. This is the focus. So this is the focal length. Let this height be h. Now if this angle is delta, they are opposite angles, so this angle is also delta. So according to the definition that we studied, power of a lens is the tangent of this angle by which it converges. This angle, tangent of this angle. This angle is equal to this angle. They are internal opposite angles. Okay, two parallel lines cut by a transversal. These are opposite angles. So these two are equal. What about tan of this angle? Tan delta, opposite side by adjacent side, h by f. So you get this formula. Tan delta is h by f. If h is equal to 1, instead of h I can put 1 by f. So we have just now studied that power of a lens is tangent of the angle by which it converges. So this is called power. So this can be replaced by power. So this is the formula that we have derived just now. Power is equal to 1 by f. So power we have studied two definitions. Now in standard 10 we had studied power is the reciprocal of the focal length of the lens measured in meters, Now in 12th standard, you have studied a new definition. Power of a lens is the tangent of, tan full form is tangent. Tangent of the angle by which the lens converges if it is concave or diverges. Now in your lab, you will be handling convex lenses, and usually their focal lengths are 10, 15 centimeter or 20 centimeter. So if this is the focal length, what will be their power? How do you find out power? What is the formula? P is equal to 1 by F. So what will be the power if focal length is 20 centimeter? Is equal to 1 by focal length is how much in this case? 20 centimeter. But we know that focal length should be in meters. How do you convert centimeter to meter? Divide by 100. So this becomes, take the reciprocal, 100 by 20. Okay, what is the answer? 5. 100 by 20 gives you 5. And what is the unit of focal length? Diopters. Okay. So I hope you have understood how you can find out the power. If you know the focal length, you have to convert it into meter and take the reciprocal. Now let us try to find out the effective focal length of two thin lenses kept in contact. Suppose focal length of this one is f1, focal length of second one is f2, then the total focal length of the system, two lenses in combination, is given by 1 by f. F is, capital F is the focal length of the combination. It is 1 by f1 plus 1 by f2. Then what will be the power of the combination? 1 by f is P. F1, power of the first one plus power of the second one. Now this diagram is figure 9.21 in your textbook. Refer the diagram. Now there is a derivation for this one. How do you find out the effective focal length of two lenses kept in contact? For this, I want you to remember the lens maker's formula. In lens maker's formula, we imagined two surfaces. If this is the object, this lens produces an image. Let it be I dash. And this image acts as the object for the second lens. And second lens forms the final image I. So this can be considered as a two-step process. ഇതേ മെത്തേഡ് ലെൻസ് മേക്കേഴ്സ് ഫോർമുലയിൽ നമ്മൾ ഉപയോഗിച്ചിരുന്നു, അതേപോലെ തന്നെ. So what is the formula for focal length of a lens? Formula is 1 by f is equal to 1 by v minus 1 by u. This is the lens equation. This we are going to apply in both the cases. Let this be the first case. Object in front of the first lens of focal length f1, you get the image I1. This image acts as the object for the second lens. And the final image you get I. So in the first case, when you apply lens equation, let the image distance is v1, object distance is u. So this is the equation. 1 by v minus 1 by u equals 1 by f. V becomes v1, f becomes f1. In case 2, this is the object. So instead of u, it is v1. Final image distance, this much distance is v. This distance is v1. So 1 by v minus 1 by v1 equals 1 by f2. Second case. You got two equations. One equation 2. When you add these two equations, adding equation 1 and 2, what happens? 1 by v1 minus 1 by v1 gets cancelled. When you are adding these two equations, we are going to add this equation plus this equation. So 1 by v1 and minus 1 by v1 gets cancelled. What is remaining on the left side? 1 by v and minus 1 by u is equal to, right side add the two, 1 by f1 plus 1 by f2. and 1 by v minus 1 by u is the combination's focal length. 1 by capital F is equal to 1 by f1 plus 1 by f2. So from this we get power of the combination is P1 plus P2. If there are more than 2 lenses, P1 plus P2 plus P3 plus etc. Okay, and if there are more than 2 lenses, what about their magnification? Power you are adding, magnification you have to multiply. Okay. Now homework, only 2 questions. Define power of a lens. What is its unit? Second one, derive the relation 1 by f is equal to 1 by f1 plus 1 by f2.